Welcome, everyone, and thank you so much for joining us today. My name is Eugene Safanov. I'm part of the marketing team at Perficient, and I'm very excited that you are with us for today's webinar, in which we'll discuss technical considerations for clinical study migration. Before we move on to a brief overview of Perficient, I'll cover some basic housekeeping items. We are recording today, so in the next day or so, we'll be sure to email you with information on how to access this presentation. All participants on this call will be in listen-only mode. This means that everyone is on mute. You can submit questions to the speaker at any time today by typing them in the chat feature, which is located on the left side of your screen. Please do make sure you state your questions clearly, and keep in mind that other webinar participants will not see who asked which questions. Your questions to the speaker will be anonymously addressed as time allows towards the end of the presentation. All right. Now that I've covered the logistics, let's just move on to a quick overview of our company. So who are we? We are a consulting firm that delivers digital experience, business optimization, and industry solutions. The work we do helps cultivate and captivate customers as well as drive efficiency and productivity. We have numerous locations across the United States and Europe, as well as offshore facilities in India and China. A little bit more about Perficient. We were founded in 1997. We are a public company that's traded on the NASDAQ, and we have over 3,000 employees. We've formed strategic partnerships with major technology vendors and also have dedicated solution and industry practices. One of these industry practices is, of course, life sciences. This graphic shows our depth of experience in this industry. You can see that we have relationships with 37 of the world's largest life science companies. I won't go into much more detail about our experience on the call, but you're welcome to look at the slide more closely when you receive the link to the presentation. All right. Now that I've covered the housekeeping items, I'd like to turn over the call to today's speaker, Richard Gavan.
Thanks, Eugene. Hi, everyone. My name is Richard Gavan. I'm a solutions architect in the life sciences practice of Perficient. I am a system administrator, a database administrator, and a software developer. Play different roles on different projects. I love Linux, probably my favorite platform, but I also work on Windows as well. So here I have a couple projects just to give you some background about myself and some of the stuff that we've been involved in. So here you see project one. For that project, this involved migrating pretty large, about over a terabyte of data, large homegrown clinical analysis and reporting application to a new hardware platform. It had been around for quite some time. It was originally developed in the late 90s. And the hardware it was on was aging and at risk, so they wanted to move it to new hardware, and they wanted to change the operating system from Solaris to Red Hat, their new corporate standard. And they also wanted to move some of the job processing to their high-performance compute grid platform. So this involved updating the code base, but also actually moving the data itself. Now, in this case, the data was in the form of SAS data sets. So in many respects, this was actually a little bit more straightforward in terms of data migration aspects, because essentially we just needed to move the files into their new location. Now, for these next two projects, these, in terms of their data migration aspects, were a little bit more complex, because instead of having a set of files that needed to be moved, we needed to move the data as it was stored in an Oracle database from one database, the source database, to its new destination. And in both of those projects and many other projects we worked on, we cannot just wholesale pull all of the data, because there are other studies in there that the previous vendor cannot allow to be exposed to anyone besides those that are supposed to be working with the study. So there's a lot of, sensitivity there, and you have to be able to export only the data that you need that is within the scope of the migration. So that's, that presents a challenge. And for both of these projects, there were kind of two parts. There's the initial part where we just migrated studies into a new database. But both of those clients also want to move at least one other study at a later point in time. And not just at a later point in time, but also into that same database that the first set of studies moved into. So that adds an additional layer of complexity, because when you're importing studies into a live database that has existing data in it, there can be conflicts. Whereas in other cases, you don't really run into this. So we'll talk about that. We'll talk about the differences between, moving a study versus merging a study into an existing database, and the, unique challenges and opportunities that that are involved there. So let's go over the agenda. First thing I'm going to do is I'm going to go over, the general migration process, and then, delineate the bit that we're going to focus on. We've had a couple other webinars this year where we've covered, various aspects of this whole process. So I'll talk about what we're focusing on specifically today. We'll talk about the difference between a move and a merge and what's involved in each one. And then we'll talk about an optional step called, but upgrading your application data and possibly converting the character set. We'll go into clinical audit trails and why and how those need to be moved. We'll talk about systems that are being migrated that have customizations that need to be pulled across as well. We'll go over the challenges and opportunities, and yes, there are some opportunities, not just challenges, and then we'll talk about some case studies. So, what is study migration? Study migration involves moving a clinical study from one database to another. So we've had a number of client requests like this where they want to move only a subset of the data that's in the source system. They want to move only the study or set of studies, not all, but some subset of studies, one or more, along with their dependencies. That's the tricky part, is the dependencies. From one database to another. And oftentimes it's from a previous vendor to their new hosting vendor for that study, something along those lines. So it includes things like the database objects, user account records, audit trails, all of that in addition to the clinical data itself. We're going to see pretty quickly that the clinical data is only one aspect of this whole process. So I mentioned we had a couple other webinars this year. The first one was in May, where we went over just this whole general concept, talked about both the business considerations and also some of the technical bits. And then we had kind of a deep dive in August where we talked about the business and validation considerations. And today we're doing the details of the technical process. So what is that? Here is the overall process, and as you can see, there are project management related activities, there are validation related activities, reports, support, documentation, but we're going to hone in on just the process of exporting the data, doing any prep work, and then finally importing it. So you see I kind of grayed out the other boxes. So the one that says development, data, export, import, that's the one where our attention is going to be. I also have the dry run and formal testing highlighted because although that's not, part of the procedure you use to move the data, it's extremely important to get feedback on whether it worked or not. Excuse me. And then there's also the validation and production boxes there on the right. And so the process that you do during the development phase will then end up repeated in validation and production. So you understand the process we do in development, you'll understand how it's going to be repeated in validation and production. Okay. So let's talk about each piece that's involved in the technical process that I outlined in the previous slide. And then after we have kind of a big picture, we'll go into the detail of each of these steps. Okay, so first part, export. We need to get the data out of the source system, and we need to do it in such a way such that, like I said, it doesn't touch anything, doesn't pull out any data that it's not supposed to. The sort of thing is very sensitive. There's a lot of confidentiality requirements, HIPAA, etc. So very important to extract just the set of data that you need if that's the requirement. And this usually involves putting together the scripts and sending them to the existing vendor, whoever's hosting the existing system. And then they review it. And typically in our migrations, they will actually perform the export. We don't get to touch the source system. We don't have access to the source system. We can only provide the scripts and instructions necessary to pull the data out. And of course, the owner of the source data will review those, and everyone agrees that this is the agreed upon process. So you need a list of tables. You need to be able to determine what's all required, and again, not just the clinical data. You need all of the data that's needed to maintain things like the integrity of the audit trail, and to keep your configuration, to keep any customization, etc. So we generally develop this list of tables by looking at the vendor documentation, by inspecting the database, and finally, most importantly, testing many times. You also need a metadata inspection script to generate a list of users that are implicated in the audit trail. And we'll go into more detail about the audit trail, but the essential idea is we need to catalog who all has touched the study, who all has made some change or other to the data that's part of the study, to the data that's being moved. You need to generate this list of users implicated in the audit trail, because it's going to be part of the filters for moving the contact info for those users. In addition to those filters, there's also the filters for the study tables. Those are usually a bit simpler. That's usually something like a clinical study ID, a unique identifier for a certain study. So if you're familiar with SQL, this would be the where clause. So something like where clinical study ID equals the number that's used for your study. Okay, sequence. So the tables that are stored in various clinical applications, pretty standard, is that they'll use an auto-generated record identifier to uniquely identify each row. So like the clinical study ID that I mentioned, that comes from a sequence, but put that aside and think of various global configuration tables, stuff like that. Those all have a number that comes from a sequence that the database automatically generates, and we need to be able to know what that last number that was used. So if the sequence is 1, 2, 3, 4, 5, and we move the data, we cannot have this sequence object start at 0. Why? Because there's already a 0 being used. There's going to be a conflict of, a duplicate record essentially from the perspective of the application. So what you do is you reset that sequence to a higher number. And the last one, the one after the last one that was used in the source database. And then you also need to pull out the custom object. So for example, Oracle Clinical, you have various derivation validation procedures within the application that depend on Oracle database objects that are outside of the application, but inside of the database. So these can be stored procedures, packages, that sort of thing, where if you run the OC level derivation validation procedure, it's going to call that database object. And if it's not there, you're going to get an error. So if you want those procedures to work in the new system, you need to move any of their dependencies. And similar remarks apply for extract macros, where you might have some kind of Oracle function that needs to be moved, and thesaurus DVGs, where you'll have a view or a table that presents some kind of list of values that are used by the thesaurus DVGs. All of these things need to be moved if you want those features to continue functioning properly in the target system. Okay, so we've exported our data. Can we simply import it into the target database? Move on to the import step. Maybe. It depends. There are two intermediary processes that we have performed in our projects, typically because clients see this opportunity to combine multiple goals into the same project, one of which might be upgrading your application. So as part of the process, you not only move the data, but you upgrade it to the latest application version at the same time. And so there needs to be this intermediary step, usually involving a staging database, where you upgrade the data so that it matches the structure of the target system. If you don't, then the target application is not going to understand your data. You're going to run into problems. You're going to have a bad time. And then the character set conversion. So for those of you not familiar with the concept, textual, text-based, alphanumeric, plus special characters type data, similar to ASCII, as opposed to things like image data. Character-based data is encoded in a certain format. The way it's physically stored in the database, you can do it in more than one way. A common standard for this nowadays is called UTF-8. It's the Unicode standard, and it supports a wide variety of international characters. It's very attractive because of that reason. And there's a lot of older character sets that do not support that. So one of the goals for a lot of clients is to move on to this newer character set that's more flexible and supports more characters, international languages. A lot of pharma is a global industry. Clients have people working in Japan and other places. So yep, important. The older standard, Latin 1, was very common. It was kind of the standard for Windows machines. Latin 1, also known as ISO 8859, did not support as many international characters. So a common request is to migrate from Latin 1, ISO 8859 to UTF-8. And again, that also involves a staging database. All right, after we've covered those pieces, we now need to import the data into the destination database. So we're going to import the tables, but we're going to disable database triggers. There's a lot of triggers in the database that do things with the data as it's inserted, primarily journaling. And by journaling, I mean it's tracking the changes to a certain table. So you might have a table where the patient data is stored, call it something like responses, to use the OC table. And you'll have a trigger on that table that says, anytime you update a row here, insert a row into this other table that has all the details of what happened, right? This is just basic audit trail journaling type stuff. But for the import, you're going to want to disable those triggers because you already have the audit history and you're documenting the migration separately, in the form of your val and QC docs. So there's really nothing additional that you want the database to journal inside. It's gonna those records are not going to make sense if you were to inspect the audit trail. So you disable the triggers. You of course document the migration in the form of your quality documents, change control documentation, validation documentation, and you maintain the history of that data as it was in the source database. And you disable the foreign key constraints. The reason for this is that when you're kind of halfway through the import process, there might be a child record that does not yet have its parent record. And if the foreign key constraints are enabled, then it's going to kick out an error. So what we do is we disable them and then enable them at the very end. As long as they all enable successfully after the initial import, then we know that the relationships between the tables, between the parent and child records, are in fact consistent because we were able to re-enable all the foreign key constraints. But during the import, there's going to be, the database will be in a certain state where a child record may be not imported yet, but will be imported a bit. So as long as you're able to re-enable all of those at the end, no issue, the integrity is preserved. Okay. The sequences. We talked about the auto-generated sequence numbers and how we need to get that information from the source system. We now need to apply it to the target system. We need to run the script to update all the sequence objects. Slide says tables, but it should say sequence objects with the latest sequence numbers, so that when the system goes to pull the next record identifier, it does not conflict with an existing identifier. And then import all of those dependencies and custom objects that we talked about, and finally import the users. And typically we do not migrate their passwords for security reasons. So one of the steps involves, essentially a global password reset where you'll need to distribute the new passwords to users, expired of course, and then they go and change it once they receive the new password. All right. Now we're going to jump into the details of each of these pieces. So let's talk about moving versus merging. So if you're migrating into a database that does not have any studies in it, then things are a little bit more straightforward. So in this situation, you create a brand new database and you install the target application in that database. You do not go live yet. You just have the base application, no data entered, no configuration, not touched by end users at all. So you have kind of like a shell, a landing spot for your study. And so all the global data, anything that's not study specific, will end up either being existing or new. So what does that mean? Existing means it's like factory data that's already there as part of the installation. New means it's coming from the source database. So you're not going to have any conflicts here. And typically, if you have new data, you're going to use that to capture the source system's existing configuration and customization in terms of the global data. The study-specific data never really ever has a conflict because of the clinical study ID providing, separation of all the records. It's really easy to move data that's study-specific. Global data gets a little bit more difficult, especially if you're doing a merge. So in the merge, your target database, and again, target is the one you're moving into, source is the one you're coming from. The target database is an already existing database. It's already live, and it has studies in it. It's being used. You're going to take it offline for the migration, but the point is that it already has study data in it. And some of that global data may conflict with some of the incoming global data may conflict with what's already there, especially if you're moving, if you moved a study from a certain database and then you move another study from that same source database, and some of the global records have changed in the interim. So what do? You need to have a conflict resolution process. And in this, normally create a copy of the target database, import like you would in the move situation, but it doesn't work, right? I mean, it works, but you get errors. So you review the log for the errors, and you compare the conflicting rows, and then you update your import script to account for those conflicts, whether you're going to keep the existing record or if you want to do some kind of update to use the incoming record. Upgrades and conversions. So if as part of your migration project you also want to move to a higher level of this application, to a higher version of this application, you need to make sure that the data gets upgraded to the version of of the target. How do you do this? Our process, we normally create a staging database and import the data into there like normal, and then upgrade that database. So say your source application is on version 1.0, just to make up a number, and your target is on 2.0, you're going to need to create a staging database at that 1.0 version number, and then apply the standard vendor-provided upgrade scripts to bring it from 1.0 to 2.0. That way, when you move it into its destination, the structure of that data matches what the application is expecting. You know, if there should be a column in one of those tables and the new version of the application is looking for that column, it needs to find it, otherwise it's not going to function. So that's the whole point there. The idea is that the structure of the data itself does change between the versions, and you need to make sure that it's consistent. Character set conversion. Again, you would create a staging database and import the data into that staging database, run the vendor provide, well, typically it depends on the application. For example, in Oracle Clinical, the vendor Oracle provides a character set conversion utility specifically for Oracle database, and you can use that to move on to the new character set. And so remember, this is in the staging database, so this is kind of like, you know, the preparation phase. You convert the character set, you upgrade the application, and then you're ready to make the final move into the target database. Now let's spend some time talking about the clinical audit trail. So we need to ensure that when we move the data and we move the audit trail tables, that we're also bringing all the necessary identifying information for users that are implicated in that audit trail, users that have touched the studies, made some kind of modification to the data in some way. These users might not even be active anymore. You don't necessarily need to move the account. You just need the contact info to ensure 21 CFR compliance, so that when, you know, some audit trail says modified by, it has a username, you can map that username to an actual identity. You map it to some contact info. I mean, that's kind of how we interpret the concept of an identity, is that you have the contact info and you could reach out to the person if needed. A username on its own, even if you do something like first name, last name as your username format, is generally considered insufficient for, you know, for preserving the integrity of the audit trail, grabbing all of the necessary information to make sense of it. At least that's how, you know, we kind of understand the situation so far. Maybe if the username was like first name, last name, phone number, but all right. So some applications do not have a straightforward mapping of users to studies they've touched, and this goes back into that metadata inspection script I talked about during the overview. This type of script needs to look at all of the existing audit trails and look for the column that holds the username that made the modification. And you need to start compiling a list of all of those usernames. Journaling / audit tables aside, the standard tables also have created by, modified by, you know, fields that hold some user for which we absolutely have to have, you know, the contact info for in order to ensure traceability, right? So for comprehensiveness, you get both the metadata from the audit trails and from the base tables themselves if they have a created by, modified by field. So this metadata inspection script compiles this whole list of users, and then you use that list to filter user-related tables, such as in OC, you would use it to filter the Oracle accounts table, which holds information like first name, last name, and you would use it to filter that table. The Oracle accounts table does not have a straightforward way to, you know, map a user to a study that they have touched at some point in the past. So that's why there's a need for this metadata inspection script. So yeah, once you move all of those journaling tables, once you move your audit trail, you'll be able to resolve what user did what at what time, because you've also moved all of the contact info. All right, conflict analysis. So say we're not just moving the study, we're moving it into a database that already has studies in it. How do you merge the data? So you attempt to import it into, of course, a copy of the target database. Similar to your standard process, but it probably won't succeed unless you're, especially lucky. So you'll have a log and you'll inspect the import log for errors, and they'll mostly be something like duplicate identifier type errors, primary key violations, and you'll write down the list of tables that have this problem, and you will reset your target database copy. You'll refresh it again so that it doesn't have all this partially imported data in it. And you will now, instead of importing it like you would normally, you would import it into a different schema. So if your schema name is called study data, you would create a new schema called study data 1, something like that, study data stage. So essentially you have a shadow, a mirror of the target schema. And so now you have two copies of each table, right? You have the target table, and you have the source table, and they're both available in that database. So why do you want to do that? Because now you can run queries between those two tables. And you can use SQL operations to identify just those rows that have the conflict. And this allows you to then pull that information out, present it to the client. Hold on one second. Sorry, I'm a bit parched. So, right, so you can use SQL operations to identify just those rows that had a conflict, and I usually put it into like a spreadsheet that highlights the exact columns within the rows that had some kind of difference. So you highlight the differences, you show what's similar, and then the client can make a decision on, okay, yeah, we can keep what's in the database, or no, we need those new records that are incoming that are currently having a conflict. And then you update the scripts accordingly to say, okay, for these specific identifiers that we found, go ahead and don't import those, or go ahead and update those with the new data. All right, customizations. So in addition to everything we talked about, the complexity of your migration may vary depending on how customized the source system was. And you need to be careful to account for any dependencies. Customizations might include customized defaults and settings, custom data for things like the source DBGs. If you have like a view or a table that contains the list of values, you might have custom programming, those stored procedures we talked about, Oracle packages, but also things like CRF logos. You need to make sure that you move the images, or are you going to use a new image and you need to actually replace it. So need to keep those things in consideration. So it's important to not only preserve the customizations you want, but maybe change the ones you don't want. You might not want the previous vendor's logo on your CRF, for example. And then you need to move any custom user roles and permissions from the source database to the target. The permissions usually handled just by moving the data by that list of tables that you generate. The roles themselves usually migrate by pulling out the source code for them, the create role statement in the case of Oracle, and then you just recreate those roles in the target database. And then when you're migrating the users, you also pull the grants and various permissions for those users and apply those in the target database as well. All right. And yeah, like I said, a lot of this gets moved just through the standard tables that you're migrating. Some of the custom objects, you can migrate them by pulling the source code, as I mentioned, or you can use the export-import tool, data pump itself, to migrate them. But it's essentially doing the same thing under the hood. Transfer any images that you want or replace, and set up the database roles and permissions. All right, so we've gone over the process. We've gone into detail into some of the pieces. So what kind of challenges might we expect to encounter? Well, there could be some heavy customization. And depending on how that customization was performed and maintained, it can significantly increase the effort, especially if the existing customizations are not well documented. We've had situations where the previous vendor might not have 100% of an idea of what all had been done, and you kind of need to go through this process of almost reverse engineering a bit and determining what the dependencies are, and are those dependencies actually customizations that need to be migrated along with the data. And you want to do this upfront. You want to do this during the beginning. If you remember the process flow I showed at the beginning, there's that development box, and then the dry run afterwards. That's when you want to be handling this. You don't want to be in the middle of the official validation and run into an error because you were missing some set of customizations or dependencies from the source system. Hard to emphasize that enough, especially because you don't have access typically to the source system, and there's going to be some turnaround time for the previous vendor, for the owner of the source data, to get you what you need. And if you're in the middle of validation, it's going to cause delays, and it's not going to look good. So you covered that during the development phase, and through a couple dry runs, you ensured that we're pretty confident that once we go into the official validation, that we'll have everything we need. Downtime is a pretty big challenge for a lot of clients. I mean, depending on the size of your data, it could take a few hours, it could take a few days to actually migrate the data. So you need to plan out the downtime accordingly. Does it need to happen during a weekend? Can it happen during the week? What are the considerations there? But usually I wouldn't plan for less than a day. You're usually going to need at least 1 day. But on the other hand, if you're importing into a new database, then you're not going to have downtime of you're not going to have downtime of any studies that are in that new database. You are going to have downtime of the source database that's being moved. Users can't enter data while it's being moved. But what that bullet point is trying to say is that if you're not merging, then at least you don't have to take the target studies offline. All right, and iterations. As I've been saying, during the development of the migration process, you're going to need one export to do it at all, right? But usually that first export doesn't have everything you need. It's pretty difficult to be able to come up without seeing the data, a perfect process for exporting it. So you're usually going to see at least 2 exports required from the source system. So you need to plan that out with the owner of the data because of their turnaround time, their resource availability. You need to keep this in mind, and you need to not try to be try not to fall prey to wishful thinking. We all want a quick migration, but if you think you're going to get this done in one shot, you're in for a bit of a surprise. And let's see, yeah, like I said, you're going to risk delays if you can't readily obtain a new export. You have to wait for the vendor to get their resources lined up, whereas if you handled this up front, you'd already have it. It wouldn't be a big deal. And if there's miscommunication, it's going to get even more hairy. All right, so yeah, those were definitely some challenges. There are also some opportunities. You can use the migration process as an opportunity for cleaning up your database. The migration affords a chance to retire unneeded dependencies and objects. So if you have a bunch of validation procedures and derivation procedures, and they're not even being used anymore, but they do, consume your time because they show up in various parts of the application. You wonder, do I need this? Is this causing a problem with this other part of the application? Any object is going to incur some amount of maintenance, and by removing those objects, you no longer have to worry about them, and you also reduce the size of your database to some degree, but that's not really not as big of a deal. And you want to avoid migrating what you think might be a dependency if it's not required in the new system. A common thought process is, well, I'll just grab as much as I can. And, if it's not used, it's not used. But at least, I have it just in case. Yes, I can empathize with that, certainly. But if you can do it without moving unneeded cruft, that's the goal. That's ideal. And you're going to be testing anyway, right? So you're going to be testing anyway. So this is a good time to do a little bit of cleanup. Another aspect of that, when you're going through upgrades or future migrations, you no longer have to worry about those obsoleted objects, which are going to come up. When someone's doing analysis for an upgrade or for data migration, they need to look at what's all in the database. And if half of it's not needed, they don't necessarily know that unless you have documentation that says it's not needed. Then they're going to have to run through. It's going to affect their analysis time for that. All right. So yeah, the idea here is that you can use your migration project as an opportunity to achieve multiple goals. You can upgrade your application. You can convert the character set that supports your now international operation, multiple languages, etc. All right, let's talk about a case study, and then we'll move on to questions. So this is actually a case study we've talked about in an earlier webinar too, but it was one that I was intimately involved in, and it covers both the move and merge aspects and some of the, a lot of the other parts. I thought it was a really good example to speak to and to showcase some of the challenges, opportunities, etc., that are involved in clinical study migration. So in this migration, we were hired by a large CRO to migrate 7 studies into a new hosted environment for their OCRDC TMS database. So because of the timelines, it was determined that the first 6 studies would need to be migrated, and then later on, a 7th study would need to be moved into that same database. So the source database was on Oracle Clinical version 5.0, and the target application was going to be Oracle Clinical 5.1. One second. Sorry, throat keeps getting dry. All right, So yeah, so this kind of covers a lot of the different aspects we talk about. They're moving some studies, they're also merging some studies, they're upgrading the data, and there was also, not listed here, there was a character set conversion from Latin 1 to UTF-8. So this kind of it's pretty comprehensive. So what did we encounter? What happened? How did it go? Challenges. There were a number of application bugs in the 5.1 version of Oracle Clinical. But did we know that at the time? At the outset, it was not clear whether these bugs were related to the application itself, or if maybe there was potentially something we missed during the migration. Now, keep in mind, this is during the development phase. This is during the dry run, right? So we identified it at that phase. So, we essentially mitigated the risk of this causing a problem down the line. But we did run into a number of application bugs, and we had to spend time discerning what the source of this bug was coming from. And, through a number of SRs, analysis, etc., we determined that they were application bugs, not related to the process we were using, and so that added some significant amount of effort. And at least one of those bugs was data specific, which is probably a more difficult version. When I say data specific, I mean the bug only arose when you had a certain kind of data, certain values, and in this case it was the record identifier was too large for the application to be able to properly handle. Like the database side could say go over 1 million, but the application side always assumed that the database would never go over 1 million, something like that. So there's this mismatch between the database and the application, and Oracle released a patch, and that fixed the issue. But we had to get there, and we got there. We dealt with this at the early stages. Which is the important part. A lot of times, clients they kind of shy away from doing multiple dry runs because it seems like it's increasing the effort. But trust me, that effort will save you a lot more effort down the line when you have a smooth validation that goes quickly and efficiently. More challenges. For this project, we did not have access to source system. Actually, most of our projects, a lot of our projects are like that. So we had to coordinate with the legacy vendor, and the timelines depended partially on their availability. So good communication, good project planning will go a long way to ensure a smooth migration. And in this project, this 7th study needed to be merged into the same database that the first 6 studies were going into. And that involved the conflict analysis process that I described earlier. Definitely increased the complexity. One option would have been to migrate that 7th study into a different database, into a new different database, and then you wouldn't have to go through the conflict analysis. But you have to think about the trade-offs. Now you have 2 separate databases to maintain. That could affect your license costs. That could affect your centralization of your global configuration, because now you have 2 copies of the global library, and that can be a problem. So it depends on how long you think the study is going to be going for and stuff like that. If the study is being decommissioned or you're just moving the study for archival purposes, then you're not expecting any changes to the global library. You may be able to save some time and effort by moving it into a new study. In this case, they wanted it all in the same database, so we did it that way. Yeah, it was an interesting project, and definitely helped us understand all of the different challenges and aspects of a big clinical study migration. It was a lot of fun. So with that, I will turn it over to Eugene and answer any questions that we have time for.
Great. Thank you, Richard. So as a reminder, if you have questions, feel free to drop them in the chat feature on your screen, and we'll just get to them as they come in. And if we're not able to answer them, we can do some research and get back to you via email or phone. Richard, if you could follow along as well, that'd be great. And I'll just read the question out loud. So the first question is, when migrating audit trails, how will you handle the change in record ID due to resequencing the records in the target? For example, an audit trail record may be pointing to record 101, but while importing, the record ID 101 has been changed to, say, 201.
So the solution there is that you do not change the record identifiers. So for the audit trail, you have maybe pointing to record 101 while it is importing, the record ID has been changed to 201. Yeah, the process does not involve changing the audit trail records. Rather, you update the sequences so that the sequence uses the next logical number that's supposed to go there. So 101 gets imported, and then when the new system goes to generate the next audit record, it generates record number 102. So the answer to your question is that you avoid having to change the record identifier in the first place. Now, there could be some situations where you have a conflict between two records that have the exact same identifier in certain situations. And there you may need to actually update it, but that's fairly rare. I think in all the migrations we've done, we haven't had to do that. So.
Perfect, thank you. So that was the only question that we had come in. If there are other questions, we'll give it another minute before we conclude.
Can I make one more general remark about the migration process? You know, this presentation kind of focused on Oracle Clinical, but I should say that it is, you know, a generic process. We've adapted it to other systems before, and it's also possible to adapt the process to a situation where you have a different source application. Say that you want to move from OC to, say, Inform or Rave. That's certainly a possibility too. Of course, we would have to adapt the process and account for, you know, the specifics of each application. But in general, this process can be used for that type of situation as well.
Great. So we don't have any more questions at the moment. I'll flip over to the last slide. So if you do have any additional questions or are interested in learning more about our capabilities or experience, you are welcome to email Jessica Knowles, who is on our marketing team. That would be great. You can also follow us on a variety of social media channels, on Facebook, Twitter. We have a very active blog. And you're also welcome to download our guides and white papers on our website and register for any upcoming webinars that you find interesting. So that really concludes our presentation. Keep in mind that over the next day or two, you will receive a link to the recording and to the actual presentation itself. So look out for that. Once again, if you have questions, feel free to reach out. And thank you so much for taking the time to join us today, and we look forward to having you join future webinars. Thank you so much to all of you, and thank you so much to Richard for presenting today.